he right? He's absolutely right. Now, Romel, tell me why.
Because in the third quadrant, sine is
Third, pi by 2.
No, second quadrant. No, it's third. Pi by 2 plus theta. Oh, yeah.
See, let's use the layman brain. This is no rocket science. Just look at this. Forget about this. Anything given here, just work out the quadrant. Pi by 2, you're here. Plus theta means you've gone into the second quadrant. ASTC, the cast diagram tells you sine is always positive. Right? And since they are complementary functions, you say this? Sine changes to cos, cos changes to sine. Right? Sine of 3 pi by 2 minus theta will be what? Chris, you're going to answer this now.
Negative cos.
Good job. Aishka, yes? 3 pi by 2, you're here. Minus flips you into the third quadrant. Tan is given as minus cos theta. Yeah. All good?
Yeah.
100%? Right? I thought probably I'll ask you. Oh, good. Let's go to chain rule now. We'll try to press the accelerator here because this all of that's done. I'm just brushing that up, and then it's just a bit more advanced as in terms of the questions that might be asked. So what is chain rule in its simplicity? Can someone tell me, please? It says, let's say if you've got certain chain rule. Chain rule. If you have a function which is a multiplication of two functions, correct? Yes or no? Yes or no? Who can tell me the chain rule? Quickly. Explain me, please. I think someone was talking about the chain rule, right? Yeah. What is chain rule? Let's talk about chain rule.
It's like for when you have, it's usually when you have something in brackets.
If you have a function of a function, the function of a function. So if you've got, let's say, a function q of x, which is f of g of x. F of g of x. Yeah, correct. Yeah. Then what do? You say your q, your derivative is the f dash g of x times the g dash x. That is chain rule. That's it. And in your Leibniz notation, you say your dy by dx is nothing but dy by du times du by dx. If you've got a function sitting within the function, then you find the derivative of the original function, the outer function, times the derivative of the inner function. That's the chain rule. All good?
Yeah.
Now, the simplest example could be, let's say if I've got, I'm just taking a book example here. So, y equals to 4x cubed minus 5x raised to the power of -2. Let's say you've got something like this. Then this is a function sitting in the whole negative 2. So what you do is, the easiest way out is, rather than blindly doing it, assume the inner function to be another function. So I say let u equals to 4x cubed minus 5x. Then what is y? Y equals to u raised to the power of minus 2. Correct? Now what are you doing after this? So you are, now that's your function. So I will find dy by du here, because it's a relationship between u and y. That will be minus 2 u raised to the power of minus 2 minus 1, which is minus 2 u raised to the power of minus 3. But I am asked, the original function was between y and x. I found dy by du. This way. I've got this bit sitting as well. Let's quickly find du by dx equals to, this simple, right? 12 x square minus 5. And then you just, now you found this as well. And then you multiply both of them to get the dy by dx. So what is dy by dx? I say dy by dx is dy by du, which is negative 2 u raised to the power of minus 3 times du by dx, which is 12x square minus 5. Brackets are very important. Yeah.
Would you express u in terms of x?
You have to, because eventually you're finding dy by dx. You need to take u off. So you sub back u in. So u is minus 2. What is here? 4x cubed minus 5x raised to the power of minus 3 times 12x square minus 5. That's your derivative. This is chain rule. Yeah.
What's this for?
Sorry?
What is it used for? Like? Wait, if you use the chain rule, like what are you doing?
When we will do a lot of application based questions, then what you will notice is that there is a correlation of not just 2 variables, 3 variables. That is where. And differentiation is not very straightforward, that you apply the basic n raised n times x raised by n minus 1. So when the differentiation becomes complicated, then this is the way to simplify it, right? I cannot just say here like negative 2 times this bit raised to the power of minus 3. That is just this bit. When you've got a function sitting inside a bigger power, you need to find the derivative of that function as well. That's the only way. Alright? Make sense? And obviously you can do it on your CAS. That'll be straightforward. Can we do a very basic, very simple? Can I take this off the board, please?
Yeah.
Yes? I'm just taking this off.
Yeah.
Can you find y equals to x square plus 1 raised to the power of whole 4? Y equals to x square plus 1 raised to the power of whole 4. Can you find the derivative of this one, please? I will match the answers then. So we are trying to now find the derivative of this value. Who's got the answer? Whatever you got, give it to me, please.
I've got 3x to the power of negative 4 over 35.
Sorry?
3x
Hmm?
to the power of negative 4 over 35.
No. Chris?
Negative 215 x
Hmm?
power of negative 615 plus 617 x to the power of negative 517.
Aishka, what's your answer?
That's what I got.
Brilliant. That's the answer. Wonderful. Now, how did we do it? Quickly. No chain rule, nothing. Simple differentiation with the first principle, right? 2 times negative 1 over 5. I'm just using that. N of x minus 1. N of x n times n minus 1. That's the f dash x, the basic first rule. Negative 5, 1 over 5 minus 1 plus 3 times 2 over 7 x raised to the power of 2 over 7 minus 1. Just solve it, you'll get your answer. Did you do this, remember?
Yeah.
So how on earth you talked about the answer?
What?
This became negative 2 over 5. Now, negative 1 over 5 minus 1 is what? Negative 6 on 5. And 99.9% this is where you've gone wrong. Similarly here, Chris, Romel, 3 times 2 is 6, 6 over 7. And what is 2 over 7 minus 1 is negative 5 over 7. No. Does it make sense? And you want me to show how this is negative 5 over 7? I'm happy to do that.
No.
100%? That's it. That's the answer. These are called rational indices. It is given a separate chapter here, but doesn't make any sense to me, right? The number still remains the same. There is no rule that I'm manipulating here. Alright. Let's throw some more challenge. One more. Can you find the derivative of cube root of x square plus 2x? Go for it.
A chain.
Good question. How do you know that you have to apply chain rule? Broadly speaking, whenever I have an expression encapsulated in some kind of a power, then an expression, not the term, then I will use the chain rule. So here, for example, here, look at these two questions. How many expressions do we have in this question? 2. 1 and 2. In this expression, the variable is just one variable and just one power on top. That's it. No chain rule. Similarly here, they can be differentiated separately. But that's the problem here. You've got this expression actually means x squared plus 2x raised to the power of 1 over 3. Right?
Yeah.
So now here, my full expression, polynomial is basically powered. So I cannot just apply a differential on individual. This is just bounded by this power, or covered by this power. So I have to apply chain rule here.
But
Unless I can expand it.
yeah,
Yeah.
that's what I did though.
Can you expand this one? Can you?
Can you?
No.
No.
I mean, you can, but then not. It's out of the purview of this book. You can expand anything in the world, but you can't expand. You can't have a cube. I can't expand it that straight away, right? how did you expand it? Just out of curiosity, can you
I
tell me?
did, you know how this, I did x squared and then on the top is 2 plus 1 over 3. And I did plus 2x to the power 1
Okay, let's go step by step. So what did you do?
x squared. And on top of the squared I did plus times a third.
And then you said 2x.
A third. No? You can't, yeah?
Alright, tell me one thing. Chris,
Yeah.
are you done? What's the answer for this one?
A squared plus 2ab plus b squared.
Why on
Yeah.
earth you did not say me a square plus b square? When you can't say a square plus b square here, why are you then doing the same thing here?
Yeah, I forgot.
Whole square. Whole. You cannot just, you say a square plus b square plus 2ab and then you apply differential individually because now you freed the terms from the whole power. The whole stuff.
So if I apply 2ab to that one, you can expand it, yeah?
This is here.
Yeah.
There's no 2ab because it's not square.
Yeah. So it's hard.
It is 1 over 3. It is like something completely different. A plus b whole square and a plus b whole cube are two different
Yeah.
formulas. It's not the same.